continue with part 2. The board have two main parts. This AC here and this DC here. The AC part power straight from house electric socket, include two T4 triac, one for the heating element, one for the air pump, and two MOC 3063 triac driver. Behind the board, you can see two snooping capacitor. The DC part power from the transformer convert from 222 volt AC to 15 volt AC. 15 volt AC go through this bridge rectifier to LM2574M regulator. This regulator power all the DC components. They use 80 mega 16A to control the board, a 8-bit MCU. This MCU receives all the button signal and temperature signal through two LMC64 of M. This digit screen here, controlled by MCU through XJ4052 CMOS logic analog. When I see two isolated power supply, I first have thought they use trailing edge method with solid state relay to control the heating element and try to lower the current down by limit the cutting time. So I plugged everything back in to see how power waveform looks like on the heating element and the air pump. Okay, now what you see is the heating element waveform. They pass full wave through triac to heating element. I think this is reasonable. If you make your own heating element, the code is much simpler in this way. You just collect temperature data and PID computing to decide how many waves you need to pass through to reach desired temperature. Now you see they stop the triac because we pushing double the power, so they cut the triac very soon. When temperature was reached, they switching the triac on and off to stable the temperature. This is the air pump waveform. They use same control method with heating element. For the heating element, I think I could put a 120 ohm resistor in series with the heating element, so we can get 240 ohm resistor with 1 amp 200 watt power rated. As my testing, you may need at least 400 watt resistor big enough to displacement the heat. Because this is AC circuit, you can replace resistor with 25 microfarad capacitor. This capacitor has an impedance of 127 ohm at 50 Hz. So the power is shared between the heater and the capacitor. The capacitor will barely heat up. You need at least 250 volt rated motor run capacitor. Or you can use a DC converter to convert from 220 volt AC to 110 volt DC. But those methods sound dangerous and bunky. You need to 3D print a new base to store those components. So I decided to open a heating chamber to see what kind of heating element they use and measure it. 220 volt heating element is very common on the market. I might be find a replacement with the same dimension. I forgot to record it, but they use a plastic snap fit to hold a heating chamber. Very easy to pop it out. They hold the heating element with a stainless steel blade and attached by 3 screws. Here it is, the heating element. They use normal cartridge heating element. I find out an interesting thing. Now they stopped using the spiral pattern to heat up the air. They just pass the air straight through the heating element. measure the heating cartridge. The cartridge had 10mm diameter and 60m length. On the cartridge, it reaches 115 volt, 100 watt. The resistance is 115 ohm. Now I put everything back and try to buy a new replacement. I blow all the white insulation material out. This is insulation material they use. I don't know what kind of material is, but I don't think it is rock wool or glass wool. For the air pump, I use capacitor voltage divider to convert from 220 volt AC to 110 volt AC and two 100K resistor to discharge the capacitor. This is all the components I need. I added 1 amp fuse in case the capacitor get broke. I have a same dimension replacement, but it rated 150 watt. I solder back the heating element wire. Now I measure my new heating element resistance, about 300 ohm. Testing my new heating element. It's drawing about 700 amp. It took about 2.5 minutes to reach desired temperature. And now the current cutting time is very close. This is my Pullman capacitor voltage divider. Protect the wire with hitching tube. Check the voltage divider. Now we got about 110 volts. Solder the input to air pump header. Solder the output to the air pump. Now I check the air pump current. It's drawing about 140 amp. I tie the capacitor to the frame. I'm making fuse adapter. The red wire have two cross plugs. Now we finished. We just need to put everything back.